Yes, hi there, and this is Koiro, and you might say that the crazy Norwegian is at it again. We're doing another round on this EuroPC, and last time when we left this up, we had an accurate picture on the screen, and we agreed that we should test the real-time clock to see if we could store anything in the CMOS and test the real-time clock chip, the M3002. And we was also going to hook up an external keyboard. As this motherboard has no external keyboard connector, we have to make our own. And a lot of today's content is going through the keyboard signals and what we have to do to hook up this keyboard. And I also promised if these two experiments was successful, both with battery and the real-time clock and the connection of a keyboard, we will try to connect an XT IDE adapter or something to see if we can boot this machine. As you might know, we don't know the state of the floppy, and we have not tested the floppy controller either, so there still is a lot of loose ends on this machine. But now just jump straight into the theory first, where we go through what we have to do on the real-time clock. Yes, as we said, the real-time clock on this is the M3200. And this is a clock chip I'm not very familiar with. I don't think I have encountered it any other place, but the datasheet for this is ready available on the internet. And while this chip is not exactly used as it is in the sample schematics that's in the datasheet, we do get a fairly good insight in how this should be coupled. And what you have here in this red square is a coupling that is meant to minimize the battery current. And this is of great concern to us because we are going to replace this battery with not a NiCad battery but with an MEHA or some other battery that is not chargeable per se. But a lot of batteries that are not chargeable can withstand a small reverse current. And we are going to modify this circuit. This circle here is how this is today, and we are going to modify this so that it will be more in line with this. And we have redrawn the schematics here so that they are more easily comparable. But we are going to solder up this battery on the all terminals. But we are going to add here a diode, one N4148 or some other small signal diode. And that's it really. Because the charging on this is not a constant anyway, it's steered by this pin here. You can see this here, this is the VBB pinout of this. And the battery I've chosen is a battery that I had laying around, and it's a 3.6 volt small cell, and this is a half size AA battery. And this battery can actually supply a lot of current, but it also can sustain some inwards current. But as you see up here, there is a warning included, risk of fire or explosion if you try to charge this battery. But the reverse current that will come to this battery if the system tries to charge this will be very, very low, so there is no risk for this battery to overheat due to this. So this is the modification we are going to do, a very small modification. We just take a diode, here this is the plus, this will be straight to the board, and here we will have a diode like so to the board, and we just cut these. So I do think that this will work, but there is really only one way to know. Before we start soldering, we need to make sure that we have the right pads on the circuit board to solder this onto. And I also want to make sure that the pads is connected as they should be. And the plus terminal of the battery should be connected to the 5 volt rail, as we can see here. And the minus rail of the battery should not be connected to the ground rail, as this is a separate pin on the controller chip. and everything seems to be okay. So now let's measure the voltage on the battery to see that this is about 3.6 volt, and we can see that it is. The negative voltage is of course because I have just swapped the pins when I measured. I'm actually using a 1N4101 diode instead of a 4148. It doesn't really matter, but the 4101 can take a higher current, and otherwise in this application they are identical, so it has no implications on the working of the circuit. Yeah, I only wrap the leads on the cathode side of the diode around the leg and make sure that it's ready for soldering, but I actually managed to do this outside of the picture frame, so I had just to cut away that footage. And I also wrapped around a thinner lead on the plus side of the battery so that it should be able to fit into these holes, and I don't think that anything will short out on the side of this, but we do have to make some measurements afterwards to see that the battery is okay. And I also think that the long leads of the battery actually is a bit of the cooling aid for when you are soldering, so I don't think it was wise to cut them away before we soldered. But let's measure, and now we measure the drop over the diode as well as the voltage on the battery, so it should be 0.6 volt lower than the battery or something. It was 3.2 something, but anyway higher than the 2.4 volt needed in the application note for the low current coupling of the M3002. So then, what about the keyboard? And here we have to do some explanation first. The keyboard that is supplied with this system is only a stupid matrix with a lot of cables running out here. And these cables actually runs to the matrix that is here, maybe like so. I'm not sure how many lines and columns there is here, but otherwise this is fed into this keyboard controller that is 68 something, and this keyboard controller is connected up to a chipset, the FE2010A, that is running a lot of the glue logic on this motherboard. This controller takes the signals from this keyboard, of course, like so, and feeds this to the FA2010 with the keyboard data and the keyboard clock here. And that is what we are trying to replicate, not this chip here. This chip is only for running this keyboard. We are trying to replicate what should be on these two lines up here. And to connect a keyboard, you can see that we have keyboard data and keyboard clock. And this is actually the pins that we need here. We have the clock and we have the data. It might seem a bit drastic just to feed into these lines and connect up a keyboard connector. If it's this simple, why didn't they include external keyboard connector or some logic for that? So I'm going to look into what other people has been doing here, or other computers that's using the same chipset. And this is how this is going to be hooked up. In addition to the keyboard data and keyboard clock, we need the plus 5 volt and we need the ground connection. All of these signals are present at the socket that is now empty for this 68 kind of chip. Here I have stated that this is an AT socket, and that is because that is the socket I know, and the same with the PS2 socket. This is also AT class. But this is an XT computer. It's running on 8088. And the FE2010 chipset is providing XT signals that is only meant for XT protocol keyboards, and while they are quite similar, they're not compatible on the protocol level. I do have some keyboards that's switchable to XT. That's probably what I'm going to use here. There also are adapters that lets you convert the scan codes and the codes from the XT keyboard to AT input and vice versa. So I did double check this on the manual for the IBM XT computer, and we do see here that the signals are quite similar, but they do mention a reset signal here. And this is a signal that I've never seen on an AT computer. So I'm going to investigate a bit further here. What is this signal? And the first thing I do is to look up into the technical manual for the Commodore PC 10.3. It uses the same chipset, and to my knowledge it's a very sturdy computer. I've never experienced any incompatibilities or some other things with that particular computer. I don't have the PC10, I have the PC20, but it's the same motherboard. Here we can see they actually gone overboard to supply this with noise suppression and other thing, and they also have this keyboard reset signal present here, and they present this as an output. So this is something that comes from the motherboard and goes to the keyboard, and if that is the case, we're in the clear for our purpose. And here you can see what they have done for noise suppression. They actually included ferrite beads both on the clock line and on the data line. And ferrite beads is this ferrite core that you thread the line through. And they actually stated here that this should be a 3-turn ferrite bead. So it looks quite similar to what you have here, or you have here. The line is turned 3 times inside this ferrite bead. And this is noise suppression, so that the signal, the high frequency noise, will be filtered out. And this is also true here, but this is more for low frequency noise, because this is actually a filter. You can see this is connected here and this is connected here. So this is pull-ups to VCC 4.7K, and there is 1 nanofarad or 1000 picofarad capacitor to ground that will actually smooth out the signals here. And after this they have included the EMI filters, and the EMI filter is like so. You have the data goes like this, and any high voltage will be dropped to ground on this. So this filter acts to suppress high voltage that comes from the plug. This is to take the low frequency noise, and this is to take the high frequency noise. So there is a lot done on the Commodore PC 10 to actually connect the external keyboard, but there is no buffers and no other things. So the FA 2010 is able to drive the keyboard without anything in between. But I'm a bit concerned to run this with external keyboards, but I will try to do this in a controlled environment, so we don't need a lot of noise suppression here. And to do a double test on this, I checked on another project that has the schematic available on the internet. This is by a guy that actually I have constructed some of his work before, Sergey Kiselev. He's been doing the Micro 8088 project, and he has also done a Micro XT one-board computer project. I went in depth into his work to see what he has done, and here there is done a reverse engineering to prove that the PT8010A is the same as the FA. Yeah, I have a small typo here, I see. This should be the like so. 2010A, like so. So no noise suppression whatsoever, if he has not omitted it in his schematics, but I don't think he have. So here the keyboard data and keyboard clock is connected straight through the output. And I'm going to test that first. If that does not work, I'm going to do this. I'm going to add a pull-up resistor. Yeah, 4.7 was used in the Commodore on both lines. And I'm also going to add this 1 nanofarad capacitor, like so. So if I can't get it to work first, I'm going to test this to see if it actually will work in my case. So I'm just going to make an adapter lead and hook this up to the missing microcontroller for the keyboard matrix, and we take it from there. So what I'm doing here, I have found a DIN connector with soldering ears that I just can wrap the leads around and just solder them in place. And I've picked 4 of these test leads, and I've sharpened the pins of these so that they will fit into the socket. And when we have finished up with this, they should be connected to the clock, the data, the plus 5 volt and the GND lines. And we should be able to plug in an XT keyboard and have that work for us. Yeah, and as normal, we go for functionality before beauty. And I think this is just ready to be plugged in. Yeah, I just cut myself when I was doing this wire. And this is the finished product. I'm just going to put the tape around here so that I'm not shorting out anything. And then I'm just going to place these wires. And we had the clock on pin 3. We had voltage on pin 4, 5 volt. And we have ground on pin 6, I think, was grounded. In here it was 21, 22, 23, 24, 25, 26 for this keyboard line down there. And this should be it for this connection. So I do think we will be ready here. And I also promised a XT IDE card, and I have one here. This is, I think, configured for BIOS address C8. Yeah, C800, I think. And it's now put for high speed. Might have to change these jumpers. And this is a 512 Cactus compact flash card. And this is a very high quality industrial grade compact flash card, and that means that this is sustainable for a lot of read and writes, and it's guaranteed to be AT compatible. So I think I'm just going to plug this in and use this when I test, just have it plugged in. So that, I think, is everything I need to do the quick test. I will just go and grab my my keyboards. I do have 1 or 2 Commodore keyboards with the XT80 switch, but I think I'm going to test this with my original Model F keyboard. There is nothing more XT keyboard than that, so that is what I will do. So I will take this just down in the shed to test it, because that's where I got my Model F, and that's where the CGA monitor is placed for the time being. Yeah, and I didn't shoot any footage of the surroundings for testing, so this is my test setup. I have my Model F connected to the keyboard connector, and I actually got output on the screen. And I will show you some of the boot up images on these, and this was not without problems. That I can start with, and I go into more detail for actually what more faults we are finding on this computer. The first thing we can notice is that it gives no keyboard error, so that's a win for the home team. But we can see that we have a video setup error, we have disk error, and we find the internal LPT port, and we are testing the base memory, and the memory size doesn't match. And that is because we haven't written anything into the CMOS settings yet. And after showing us the setup options, it goes ahead to start booting from the XT IDE, but it can't find the internal device, and it can be many reasons for that, but we are going to actually boot the computer again and enter the setup menu to see what we can find inside. And it boots with exactly the same errors as it did last time, but then again we have not been inside the setup and tried to save any settings anyway, so that is to be expected. And here we can at least see that the keyboard is working. We are entering the setup and everything is in German, so we try to change the settings to Norwegian settings to see how that goes. And in the background you can hear the lovely clicking sound of the Model F keyboard. And the BIOS is quite straightforward. It's the page down and page up to change values, and it's the arrow keys to change between the menu items. And then it's return to save settings and exit, and escape to key just to exit the setup program without saving anything. And we first adjust the clock and date. But then we see some other things that we did not expect to see within this setup. It states that it's no LPT port, no address for this, even though we found it in the post. And the memory is 640K. This machine counted up to 512K. The first thing I'm going to do, I'm going to try to save the settings as they are now. Otherwise, I'm going to try one of the other BIOSes that we burned on EEPROM for this computer. The startup sequences and the beeps are the same as they was before, but here we can see that the BIOS is booting with the same errors and the same omission that was last time, so clearly the setting was not saved. So I'm going to straight away change to another version of the BIOS, and we can check if the same is happening on that version of the BIOS. Strangely enough, after the reboot, the LPT port shows up in the BIOS settings screen, but otherwise all the settings was like they was before, so nothing is stored in the memory of the real-time clock. This is the newest BIOS I could find. This is the 208 BIOS, even though it says setup version 1.2 in this menu, and this gives us a slightly better result. I see that the LPT port shows up as it should, and we do have a slightly difference in the settings for the video adapter. But let's see what's happening when we try to save the settings we have here. We also try to increase the CPU speed a bit. But from the start here we see that this does not look good. It has the video error and it has the disk error, of course, and it has the memory size doesn't match, and that should have been the case. And if we go into the setup menu again, we see that the settings has not been saved. So what have we learned here from this testing? And that is that this M302 chip probably is bad. And why do I say that? Yes, because this is where the CMOS settings actually are stored. In addition to being a clock timer, this also has a small amount of memory present. And this chip, I have tested every aspect of it from the outside, and it appears to be working. The only thing that I can say for sure is that it doesn't store anything in memory. And there is also a test procedure that we can use on this chip to test it, and I've tried to test it. And here it's described how the RAM access actually work. And it's a pretty throughout description of this. And the test procedure to test this is that you can test this in a bank and feed it with data according to this truth table. And I've tried that. I also tried to feed it manually with the clock signal and everything as it stands in this test setup, and tried to apply some settings, but I can't get it to store anything. But of course, I have tested all this without a NiCad battery. The only thing I have is the battery I've soldered in here, but I've tried with the same kind of battery without any diodes, so we actually put charge into the battery, but to no avail. It happens all the same. And I also tried the last modification and did the battery thing with only a small resistor, or not a small, I take a 1K resistor in series with the battery to avoid any serious damage to the battery because it was being charged. But that did not help either. So the M3002 chip is probably bad. Otherwise, I've missed something in the test procedure, and there is some other fault that makes this not work on the computer. But we actually have more fault than this, and you didn't see any mention of the serial port when it booted. But the serial port should also be present, as it is not disabled and it's connected to both the address and the data bus. So there must either be something wrong with the serial controller chip, or there is something wrong with the buffers leading into that chip. So that's one more fault, and the M3002 is also bad, needs to be replaced. And in addition to that, we saw that we couldn't boot with the XT IDE adapter. But that's probably not a fault on the computer or the XTI adapter. It is probably the serial port on the parallel port on this machine is set up to be 3BC. That was the original address that was chosen on the original IBM computers, rather than the 378 and 278 address that was chosen on later computers. And bad address decoding on that can lead the XT IDE adapter, especially this adapter that I have set up, to use address 300 as the memory I/O address for communicating with the drive. And I can change that. I can just burn a new PROM and reconfigure it to use another address, and then I think the XT IDE will work just fine, but I won't bother with that. So this will be the last episode this year regarding the EuroPC. In the next installment, I will try to order a new M3002 chip. They are available, but I don't know if they are new on shelf or counterfeit devices. It's no way to know before you have tried. But I'm going to try to replace that chip too, and if that fails, I'm going to give up this project. If I'm actually able to save something to the BIOS, I'm going to continue at least one more step to see if there is some more faults on this poor old computer. So that's it for this episode. Hope you have enjoyed following this project. Hit like and subscribe if you want to be notified when we post new videos. Please tell your friends that these videos exist. I do have a goal of reaching about 1,000 viewers, and I hope to reach that goal in the first half of 2023. And I will probably post one or two more videos before year end, but that will be on totally other topics than the EuroXT. So happy Christmas to all of you, and see you in the next one. Thanks for watching.